want to show you a few other designs that fall into the category of observational studies. Case reports and case series. So a case report is a description of a particular disease or a particular case. A case series is several descriptions of cases related to each other. They're considered weak for causal inference, but they can be very useful. Describing a black swan event which proves that something is not always the case. So if I say that not everyone that smokes for 50 years develops lung cancer, well then it only really takes one case to prove this. I only need to find one person who smoked for 50 years and doesn't have lung cancer to prove that statement. They are useful for alerting for early emerging infections, which seem at odds with current knowledge. Unfortunately, the human mind is prone to believing a good story above good statistics. So one has to be very careful when putting out case reports and case series because they can be very convincing. As we know, vaccine and autism connection was retracted, but from the Lancet. This case series report suggested that onset of behavioral symptoms was associated by the parents with measles, mumps, and rubella vaccination in 8 of the 12 children. And this has been since retracted, as you can see from the Lancet, but nevertheless, it did a lot of damage and has spurred on anti-vax movements and so on. A case crossover design allows a person to be its own control, comparing exposed and unexposed time. It's useful and only really possible if exposure effects are short. So if I wanted to investigate if physical activity in the past 24 hours caused heart attack, I could find cases of heart attack, ask about physical activity the 24 hours preceding the event. And then I could ask the cases about 24-hour periods where no heart attack event was recorded. It's also possible in a randomized trial to actually swap the intervention and control groups after a period of time, if there is a known washout period, so that the effects of treatment actually have disappeared with a known period of time. Finally, cross-sectional. When all measurements are done at the same time, there's no distinction between baseline and follow-up. Easiest to think of this as a survey. Possible to measure associations. Causal arguments are harder, very much harder. If recall can be guaranteed to a satisfactory degree, then asking about past exposures and current disease can to some degree elucidate causal connections, but many biases play a role here. Multiple cross-sectional surveys do not necessarily help. How do the two populations surveyed relate to each other? Are they the same people? So you can imagine we did a survey on university students, on first-term university students as they come to university. That doesn't constitute a follow-up because it's a new cohort every year. So how's that going to help you make a connection? A special design of cross-sectional studies, special design of survey design really, can actually help you to measure causal constructs. This is an interesting paper which I recommend reading, and it estimated or investigated the effects of reminders of personal sacrifice and suggested rationalizations on residents' self-reported willingness to accept gifts.